This is to demonstrate how our application works using UML sequence diagram. So we have a very simple form SNS website where the user can request the form and get the data from the database. The API is responsible for making that GET request. And when the user submits the form using his data, the API is responsible to post it into the database. So the tech stack of the application is for front-end, we are using JavaScript and HTML. We have a separate Docker file. For this, we push this to Docker Hub. For the API, we use Python Flask. We also have a separate Docker file for it. And for MongoDB, we are using pre-pulled Docker image from Docker Hub. Once we have all the 3-layer separate images in Docker Hub, we have separate YAML files to deploy them using Kubernetes. Now we can see the website in action. So this is our website, how it looks like. The user can... this is the form, how the user gets. He can enter data. So let's make a post data. And we can check the API. So this is the last data we entered, post data. We can also check in the database if the data was there. So post data. Now we also have retrieved the data from here if we refresh the page. So both get and post works. Thank you. This video is to demonstrate the artifacts that we build for our application and how we deploy those artifacts. So the artifacts by we mean the Docker file and the images. For the front end, we have, as mentioned, JavaScript, an HTML file, an HTML with JavaScript file. So we have a Docker image for it. Once we build that Docker file, we get an image and that we push it to Docker Hub. And the same goes for the API. We have an application, Python Flask application and a Docker file, which is responsible to build that application and create an image and push it to Docker Hub. And we can check the code here as mentioned before. So this is for the 3-tier, the front end. We can see the code here, the application. It's an index.html file. The front end this is the index file for the front end. We also have a Docker file, which is responsible to create the image. Also, the API, we have a similar format for the API as well. The application is the Flask Python, and this is the Docker file for it, as shown in the diagram here. So we have pushed the respective images to the Docker Hub. This is the repository for the front end. This is my repository, and this is for my colleague where the API is pushed. So we are using this version, and for the front end, we are using this image. For the database, we are using directly from the Docker Hub. So we don't have a Docker file for it. We are using the image from Docker Hub with MongoDB. Now for the deployment, we have the YAML file separately for each 3 layers. For the first front end, we have a front end YAML file. In one YAML file, I've configured the workload deployment and service. So once I run one file, it is faster because it creates both the deployment and the service. This one is of type load balancer. And also for this, we have ingress in place with certificate. This is also another artifact. So for the API, we have a similar layout. We have the deployment file. When we run this deployment file, the service also gets created. And this file makes use of secret and the config file. From the config file, it picks up the database URL and the database username password from the secret file where it is supposed to post and get the data from. And for the database MongoDB deployment, we use workload deployment here, and we are using environmental variables, and in there we use a secret referencing to the secret file where the database username and password is saved. This is the secret file. And also we have persistence volume in place for the database. That's in a separate video, but since we are showing this file, we can also see that persistent volume claim is also added here, and we can see that the database is not exposed. It has a cluster IP, so we can see the application also here. So this is the front end of the application, and as mentioned in the sequence diagram here. The user can get the form with the data from the database. The API is responsible for it. And once the user submits the form with new data, the API posts the data in the database. So we can see that here as well. So this is the front end. This is the retrieved data from the database. That's only one data. Now when he wants to post another one, it goes via the API as mentioned here. So it posts the data in the database, and here it is again getting it, and we can check that post was also successful here once we see that then second data is there. So that's how our application works in 3 layers: the front end, the API, and the database. To demonstrate the storage class for our database, MongoDB, I have created a persistence volume of storage class type microkits host path. I have created a folder here which is of MongoDB data, and I have mounted here the host path. So next I have created a persistence volume claim. This got bound with the persistence volume because the request matches with it. Here we can check the persistence volume first created, and it got bound with persistence volume claim. The claim policy is retained, which means the data will remain even if the pod crashes. This is the path where the data was saved on our disk. We can see here. Also, we can check how the deployment file was configured using the persistence volume claim. So the claim name is PVC MongoDB. This is this one. And the storage class is a microkit host path. So this is for the microkits. We have also done separately for the Google Cloud platform. Thank you. This video is to show how to configure TLS for website. So we have 2 services, one for the front end and one for the API. The front end and the API both are of load balancer services, and have configured TLS for both of them, a self-signed certificate using Cert Manager. I've installed MetalLB on microkits, and I'm using Nginx ingress controller, and I've created 2 ingress resources, one for the web and the other for the API. After I have disabled ingress, created the certificates, created my issue certificate, added my ingress secret, both of them to the root. We can check that in the terminal. This is my secret certificate for the web, which has the host name of my SC-GRP web, and it is issued by my issuer by Cert Manager. We can also check that for the API as well. So both have the TLS configuration in place. This is for the front end, which still says not secure. And if we see the certificate, this is for the front end and this is for the API. We can see the certificate that was self-signed by using Cert Manager. And this is the host, the domain for the front end, and this is for the API. This is to demonstrate the network policies for GKE. So following the guideline mentioned here in Canvas, I've applied the network policies for our cluster. So now we can check that the network policies are enabled for the master and the worker nodes. This is the cluster, fancy cluster, and I have applied 2 policies to the cluster. One is deployment DB allow and API net allow. We can check the policies by doing a kubectl get network policies. So for the API, both ingress and egress is applied. Here, if you see the policy types, and here, ingress is applied to the pods that match with the app and the role here. So, and also that goes same for the egress with MongoDB and DB. So the traffic is allowed only that matches with the app and the role. That's for the API net allow, and for the DB to limit the traffic going in and out of the DB pod. We have applied this to the database, and here we can see the same thing. Thank you.